I'm Teacher Ma. Over here, we're going to go through one of the questions from year 2020 and paper 1, question 30. And even though it's a paper 1 question, but still, we can get a lot of mistakes inside this one. So let's take a look. Over here, let's read the question first. We have a trapezium ABCD and right angle triangle ABE that are drawn onto the square grid inside the box. Over here, we have a triangle ABE or ABE. And we have another one, trapezium ABCD inside the dot grid. And then we need to, by drawing dots on the grid with straight lines, we need to draw another trapezium ABCF such that AF is longer than BC. So not just this one we have, we need to draw another one, trapezium. So first of all, what is a trapezium? And what's the property for a trapezium? That's a problem. So for a trapezium, we have how many pair of lines? Parallel lines. Only one pair of parallel lines, and the other pair cannot be parallel. But the problem over here is how we draw parallel lines inside the grid. Not gonna say that AB is not even straight lines, it's slanted lines, and BC is also slanted. So how to draw parallel lines? Is it test any point over here, for example over here, and then connecting? Oh, wait a minute, hold on. Let me go back and let's try it. So is it like finding another point like over here or like here and then connecting? Is it parallel? Maybe not. So here's a challenge, how to find the parallel lines. And another challenge is that the second part asking draw another triangle ABG such that it has the same area as triangle ABE. But also triangle ABG must not overlap with the trapezium ABCD. So we have triangle ABE. Then we need to find a G point that share the point of AB. But where can be the possible G point have the same area? That's a problem. So one way is if I reverse it to put back over here. Does it work? Actually, that doesn't work. Why is it? Because we must not overlap with the trapezium ABCD. So this one, it works. It has the same area, but it overlaps with ABCD. So this one doesn't work. But how to draw the same areas? Here we have another problem. So to tackle these two problems, let me give you some hint. First of all, let me show you one of the square grids. We have a lot of dots over here. And for example, if we have a straight line, to draw parallel lines to these straight lines or even draw the same length for these straight lines, it's very easy. We just draw, over here we have how many units? If this is 1 unit, we have the length which is 3 units. So to draw the same length, we can just draw same 3 units because it's horizontal. And vertical lines, we can just, over here also 3 units. So vertical lines, we can also draw vertically. But the problem is, how about this kind of slanted lines? For this kind of slanted lines, how to draw parallel? Or even how to draw the same length? Because for those horizontal and vertical ones, we're able to measure it. For example, this is 4 units, this is 3 units, this is 3 units. But for slanted lines, are we able to find how long it is? Not really. So here we have a problem. How can we transform from these slanted lines to something that we can measure, which is horizontal and vertical? Now, let's think about it this way. For this slanted, the horizontal way we cross how many units? Yes, over here, I just crossed 1 unit. And it crossed how many units vertically? And there's 2 units crossed vertically. So in this way, what we can form is, over here, horizontal 1 and vertically 2, we are forming a rectangle. Now, the slanted line now became what to this rectangle? You can see its connecting is diagonals. So in another way, to draw the same length, we can draw a same side rectangle. Should be how much? What by what? So the rectangle we draw should also be the same size, 2:1 or 1:2, and then connecting is diagonal. And that will be the same diagonal we draw, same slanted line we draw with the same length. But to just draw the same length, that is not the only way. We can also draw in another direction, for example over here, but same side, still 2:1, and then connecting the diagonal. Over here, also same length. Or even over here, that also same length. Or Another one. Another direction, but also same length. So actually to draw the same length, we have 4 directions. So let's name it 1, 2, 3, and 4. But which one is parallel to the first one, to the original one? Which one is parallel to the original one? Yes, only the first one. Not just the same size rectangle, but also the same direction for the rectangle and also for the slanted line, for the diagonals. Same direction. So that's how we draw the parallel lines. For example, over here, this slanted line is to form what size rectangle over here? Yes, let's draw it. We can form one unit vertically and 3 units horizontally. So we can draw a 1 by 3 rectangle. So by copying this, draw the same parallel lines, we can also draw 1 by 3 rectangle and then connecting the same diagonal. That's how we draw the parallel lines. So by understanding this, let's take a look at this one. So the first question is, draw another trapezium ABCF such that AF is longer than BC. And we have AB, we have BC. So which one will be the parallel line? If AB is the parallel lines, that means C to F should also be parallel to AB. And this is very easy to find because it's just on this line. But is any other point we can use? Can F point on the other side? Actually, no, cannot. Because there will not be a trapezium. So it should be on the left side of C. But over here, can we use this point as F? I cannot, because that will form what shape? Is that a trapezium? No, it's not. It's actually a parallelogram, not trapezium. So cannot use this point. How about D point? And that will be the same, but also the AF is not longer than BC. So also doesn't work. So it seems that AB will not be that parallel line. So which one will be the parallel line? Yes, BC will be that parallel line. That parallel to AF. So now the problem is how we can draw the parallel line that is parallel to BC. So about slanted lines, we can transfer into the rectangles to draw. So for example, this slanted lines, we can transfer into a size of rectangle that is 1 by how much? 1 by 3. So after we transfer into a size of 1 by 3, and we need to draw starting from A by what size rectangle? Yes, also 1 by 3. So we draw a 1 by 3 rectangle, and then what should we connecting? At the diagonals. We're connecting the diagonal, but over here, stop. Does that point work? No, it's not, because the AF should be longer than BC. Then what should we draw? Very good, just draw additional one. If one is not working enough, not long enough, we draw another one, but with the same rectangle. Starting from the other point, we draw a same size rectangle by 1 by 3, and then connecting the diagonals. So over here, that will be the F point. So F point label over here. So that will be the rough paper and using pencils to write. Don't like me. I just randomly draw. But in actual life, you need to use the rulers and pencils to draw it. So after we draw the rectangles, let me use a blue pen to draw straight lines connecting AF. Okay, great. And then also connecting CF. So that will be the answer. And also, don't forget to label the answers F. So first question has been solved. To draw the parallel lines to the slanted, we can transform the slanted line into what size, what shape? Rectangles. And then we draw the same size rectangles. And the difficulty comes to the second question, which is draw another triangle ABG such that it has the same area as triangle ABE. How do we draw same size rectangles? Oh, same size triangles. By understanding this, let me show you one of the examples. Over here, let's say a blue pen is not showing enough. Let me use black. Okay. Now, what I'm gonna have is one line, and draw another line that is parallel to this line. Oh, a bit slanted, Let me change it. Okay, that's it. So we have two parallel lines. And now, what I'm gonna do is, inside this parallel line, let me create a triangle. A, B, and C. So for this triangle, we have the BC is the base and the tip is another parallel lines. And what happened is, I draw another A. This is point A slash, and then connecting BAC and AB. Now let me ask you a question. So for the triangle ABC and triangle A-BC, the areas is word relation. A is actually the same. But why is it the same? The base they have, the base for these two triangles is which base? They both have BC, so the base is the same. So same base, same base. But how about height? The height they have is word relation. In another way, how to find the height? To find the height of ABC, we need to draw from the tip, which is A, to draw a perpendicular line that down to the base. So if I need to draw a perpendicular line down to the base, and then that will be the height. And also from another point A dash, we also need to draw a perpendicular line that perpendicular to the base. Now, since these two lines is parallel, so the height they have is word relation. Also the same. So same base, same height. Same base, same height. The area should be what? The area should also be the same. Same area. Same area. So that's what we can get. So in between these parallel lines, the two triangles area is the same. But actually, over here, if I give another point, A slash slash, this point, I'm connecting BC, B and C. Now, we have two triangles, A slash slash BC, ABC, and A slash BC. These three is word relation. Very good, all the same. Because still, same base, same height. Or in another way, the tip, I can move in anywhere inside these parallel lines, and the area, does it change or not? And it doesn't change. It's like moving a curtain. So in this way, we call this as curtain model. Curtain model. Curtain model. But how to use this curtain model? See, for the triangle ABC, the base, one of the base is inside one of the parallel lines. But the tip is in where? The tip is another parallel lines. For example, A is in a parallel line that is parallel to BC, so that makes the same areas. But understanding this, let's take a look back to over here. So still, we have A, B, C. We need to draw the same size. And we need to draw an ABG. And which point is shared, is fixed? Which point is fixed? ABG, ABE. So AB is a fixed point. So we need to find the G point other than E. So the problem is, the base should be which one? The base AS, the base should be AB, and the tip will be which one? If the base is AB, the tip will be the E point. But if I need to draw another tip that is same area, so another tip should be in what kind of lines? Yes, in a parallel line. So in this case, we need to draw a parallel line that is parallel to AB and starting from E point. Again, how to draw parallel lines? Yes, rectangles. So over here, let me use red pen to represent. Okay, over here, let's take a look. For AB, we have 1/2 rectangle. 1/2 rectangle. I connected the diagonals. So from E point, I also need to draw a what size rectangle? Yes, draw a 1/2 rectangle. So over here, we need to draw a 1/2 rectangle and connecting the diagonals from the bottom left to the top right. Bottom left to top right. And not just it. Maybe the line should be longer, so we can extend the line. For example, like this. Now, let's take a look. We have AB is inside one of the parallel lines. Let me erase this. We have AB that is inside one of the parallel lines. Yeah, let me move this. Yeah, hold on. We have AB that is in one line, for example over here, and E, the tip, is in another parallel line. So where can be the possible G point? Yes, anywhere inside these parallel lines. So which point will be the G point? Actually, this one can be the G point. And if we're connecting it using a blue pen, so the G, we have GB and GA. So let's connect it. So let's visualize. We have ABE and ABG. The base we have is which base? Yes, it's AB. They both have the same base. And the height they have is from where to where? The base they have is actually EB, the right angles. And the G, to find the base, is actually draw a perpendicular to the base. And that will be the height for another triangle, ABG. So the height they have is word addition. Also the same. So in this case, these triangles, the area should also be the same. To draw the same size rectangle, same area rectangles, we need to draw parallel lines from the tip, then parallel to the base. So that's how we do it. And actually, that is not the only answer. For example, we can also have a G point over here. I'm connecting GB and GA. Another triangle. The base is the same, the height is the same, because it's the distance between the parallel lines, so the area is also the same. So that's how we solve it. So overall, let me create another one. By drawing rectangles, we draw another point. Yeah, not this one. Here, from F. This is F point. So that's how we solve the problem. So let's do a summarize. First of all, to draw parallel lines that parallel to the slanted, how to draw it? We transform slanted into what kind of shapes? Yes, we transfer slanted into rectangles. We transfer slanted into rectangles and draw same size rectangle. And connecting their diagonals. And second thing is, how about the same size triangles? The triangles we have is actually the triangle in between what kind of lines? Yes, parallel lines. So basically for the curtain model, for the curtain model we have is triangles in between parallel lines. And the base is inside one parallel line and the tip is in another parallel line. So that's how we form the curtain model and use it to form the same size triangles. So over here, you can try this question one more time or maybe a few days later to check whether you fully understand or not. So if you want to learn more about PSLE, you can try to scan this QR code to join our study group and help you to solve doubts. And also, or you can directly contact me by scanning the QR code over here. And okay, see you soon in our next time. Bye-bye.